Ladies and gentlemen, it is 4 p.m. on Tuesday, the 4th of May 2021. That means it is time for a brand new epic product launch, live from Mission Control in Northbike by the Sea. We have selected 5 epic members who each have an important development to announce to the rest of the world. Today, those companies are NIREOS, Xenics, Class 5 Photonics, Laser Components, and Edmund Optics. Let's open up the sunroom and get started. Welcome everyone, welcome to another epic product launch. My name is Jose Pozo, I am the CTO, they call me the Chief Technology Observer. My job is to observe technologies of the 700 plus epic members and try to find for them potential suppliers, customers and partners. Today we have a fantastic agenda, 5 new products here to make a difference, a revolution in the photonic industry. We have the hyperspectral camera HERA IPERSPETTRALE from NIREOS with high resolution and low light conditions. We have the new LWIR camera of Xenics Ceres T 640. They actually provide high accuracy with stability. Class 5 is going to show us the Moonlander HHG, perhaps the coolest name in the history of photonic products. Landing in the moon, a full pan probe measurement for time resolved spectroscopy. Laser components is going to show the FLEXPOINT MVpulse, a new laser solution with tunable power and pulse length for the machine vision industry. And last and definitely not least, we have Edmund Optics talking to us about the new portfolio of super polished optics. Let's get started. I can't wait anymore. Let's get started with a big thing in this industry, a new hyperspectral imaging camera making a difference in the low light conditions. We have with us nothing less than the CEO of NIREOS, a new company that is making a difference in hyperspectral, Fabrizio Preda. Thank you very much for being with us. The floor and the attention of everyone goes to HERA IPERSPETTRALE, goes to NIREOS.
Hello, everyone. Thank you, Jose, for the kind introduction. So, hi, everyone. I'm Fabrizio. I'm the CEO of NIREOS. And today I would like to introduce the new HERA IPERSPETTRALE hyperspectral camera. Just a quick introduction on the company first. So NIREOS is a spin-off company based in Milan, in Italy. We are a spin-off company of Politecnico di Milano University. And we founded the company 3 years ago. So in 10 days, it's our birthday now. In the last 3 years, we have grown quite a lot. We have 10 people employed now, and more people are expected to join us soon. And we have, let's say, 60 years more cumulative expertise in photonics and spectroscopy. So the main customers we have are basically scientific and research centers. But in the last months, we are starting to target as industrial market as well, as our devices, let's say, and spectroscopy devices in general can be very well suitable for quality controls checks in production lines, for example. This is the product portfolio that we develop and sell. 2 interferometers called Gemini and Gemini 2D, and the HERA hyperspectral camera, which is the main topic of today. So all of these devices are based on the same technology, which is the Fourier transform approach. As you may know, this is the working principle of FTIR spectrometers. In this approach, the spectrum, let's say, of the light, the spectrum of the light can be measured, and it is measured thanks to an interferometer, which creates 2 replicas of the light, of the input light, which are with a variable delay tau. And by scanning and controlling this delay tau, at a single pixel detector, an intensity signal called interferogram is measured, and the Fourier transformation of this signal directly provides the spectrum of the light. So our hyperspectral camera works in this exactly approach. The only difference is that we extend this working principle to the bidimensional case. So we replace the single pixel detector with the bidimensional sensor, so that two replicas of the scene we are looking at are measured at the detector as a function of the delay tau. So at the end, the detector collects a time domain data cube, so a stack of multiple images acquired at different delays, and then pixel by pixel, the software performs a Fourier transformation so that the spectrum of the light at each pixel is retrieved, thus the entire hyperspectral data cube. This is a schematic and also a picture of the real device. As you can see from the schematic, it's really, the schematic is really simple. So basically we employ the common path interferometer in front of a camera lens and the CMOS camera in the case of the visible hyperspectral camera. And the main, let's say, advantages or features of this technique are the following. So first of all, it's a staring technique. So it's really suitable for a static object. There is no need to move the camera with respect to the sample during the measurement time as required often by competitors' technologies. It can deliver high throughput and high sensitivity. And this basically is related to the fact that no slits or gratings are employed in our camera. And also the spectral resolution can be easily varied via software, as it is only determined by the travel range of the interferometer in front of the sensor. This is just a quick video to show how to operate with a camera. You can see that it's really simple and straightforward. You can mount it on a standard tripod, either in vertical or horizontal position. Here in this example, we are using a couple of halogen lamps, quite weak in intensity, like 20 watts halogen lamps. And in the example, there is lettuce as a sample. I will explain to you in a second why lettuce. And that's basically it. With the camera, we deliver also software, which is plug and play. So you connect the camera to the power supply, to the computer via USB, and that's it. You can start the measurement and acquire directly the hyperspectral image. Why lettuce? That's because recently we have started to collaborate with a vertical farm company here in nearby Milan. It's called Agricola Moderna, and they have a huge greenhouse where they grow vegetables and lettuce in this big, let's say, greenhouse. And we are using our hyperspectral system to characterize the health of the vegetables and the shelf life as well, both in reflectance and in fluorescence. In fact, the high sensitivity of the camera enables to measure hyperspectral images of the fluorescence signal emitted by phenols or chlorophylls, which are typical contents of the leaf themselves. These are some results. So you can see reflectance and fluorescence spectra as a function of the days after harvesting. So you can see how the spectra evolves in time. And so you are able to characterize, for example, the shelf life of the products. We created this kind of NIR index. And here you can really study and characterize, let's say, the shelf life of the samples themselves. So it's really, really working nicely in this application. This is just some images of the measures that I showed you before. You can see on the top line the RGB projection of the hyperspectral data as a function of days. So day 1, day 12, and day 19. You can see how the color in the RGB projection of the leaf change. And also with the chlorophyll index, you can really tell which is the chlorophyll concentration. And you can see that the chlorophyll concentration decreases as a function of time. So these measurements were conducted in the visible near infrared spectral range. But now in the near future, we are going to replicate these measurements in the infrared as well, as we are developing also the infrared versions of the hyperspectral camera. So with that, I would like to thank you a lot. And Q&A session, I'm available to answer all your questions. Thank you very much.
info@nireos.com. If you have a request, a comment, a challenge for this revolutionary hyperspectral camera, HERA IPERSPETTRALE, please contact Fabrizio and get in touch with them. Fabrizio, this is an epic meeting, and you know what it means? Everyone gets the first same question, the epic question. What can you do for them? What can they do for you?
Yes, so I think that as I was mentioning, we are targeting a lot now the industrial market. So any application, any suggestion or collaboration or projects that can be conducted together, we are very open to evaluate with everybody. So on our side, we can deliver this nice technology and performances. On the other side, we are totally open to collaborate and find novel applications.
One of the issues that we're having with the hyperspectral imaging is that it wants to be used in process control monitoring. It generates a lot of data. So we need to actually monitor in many different points along the line. And the data processing is, it has been a challenge for companies in this sector. I wonder how you see this as an opportunity or as a challenge, and you maybe have a solution for that.
Yeah, it's quite a challenge. I mean, the data handling then is very complicated as the data is very big. So on one side, I would say for, let's say, R&D projects or let's say development of new application, that can be bearable, I would say. But for production lines, I would say that also multispectral imagers are very suitable as well, as they may be produced for that particular application. And in that devices, the amount of data is much smaller, so much more easy, let's say, to handle. And that is why maybe in a new product launch, we are going to launch the multispectral camera we are developing for these production lines applications, I would say.
In many applications for hyperspectral, we always have to go to low light. We need to go to places in which they have a lack of illumination. On that, the sensitivity of the sensor is perhaps the biggest challenge. You have from the very beginning positioned NIREOS as an ultra high sensitive company. I'm not going to ask you what's your secret, but what's your secret?
No secrets at all, in the sense that this is determined only by the technology employed. We do not need to employ slits, which are typical, I don't know, 10 or hundreds of microns small, that limit a lot the throughput of light, and no grating. So we have 1 centimeter clear aperture in the front of the device. So a lot of light can impinge on the sensor. And also by employing the Fourier transform approach, there is no color filtering on the sensor. So simultaneously, all the colors of the light impinge on the pixel of the sensor. So the energy at the sensor is much higher than with respect to filters-based technologies, for example, or push brooms. So these are the two main reasons why the sensitivity is so high.
I think on that is when you make a very big difference from your competitors. I'm very happy that you chose vertical farming as a use case for this presentation. How do you see that market growing with respect to hyperspectral imaging? It's the beginning. We are touching the tip of the iceberg, right?
Yeah, absolutely. Yes, completely agree with that. I think the potential is huge out there in the vertical farm, and more companies are now converting to these kind of technologies, and they are realizing the potential of this technique, I would say.
What I want to see more and more is drones actually carrying hyperspectral imaging camera in fields. Is there an easy supply chain for you to reach that kind of segment, to work with companies who actually manage to have observation with drones of farms?
This is an application we did not test it yet, I would say, but again, very open to do it. The only difference with respect to standard technology is that the drone during the measurement has to stay static on top of the sample, let's say, or on top of the scene. Otherwise, with our technology, with our approach, the measurement will be blurred. So you need to stay still with respect to the sample during the measurement time, which is approximately 10 seconds. So that's the only requirement for drones application.
Fabrizio, congratulations.
Thanks
Congratulations. We need more companies like you in Europe. You are making a difference, and you are positioning European hyperspectral imaging at the top, and it's where it should be. Congratulations. Thank you very much. We move on with the program. We go now to Belgium. We go to Xenics, because we have with us one of the manufacturers of the best mid-infrared cameras. We go to the LWIR camera for thermography, the Ceres T640. And presenting that new product making a revolution in imaging in Europe, it is Marc Larive, the strategic marketing manager of Xenics. Please, Marc, tell us what we can do to make Xenics even greater, even more amazing than it already is. Let's hear it for the Ceres 640.
Hello everybody. Okay. Yep. Okay, so thank you very much, Jose, for this nice introduction. Let me today introduce the new product from Xenics, the Ceres T640. As you said, it's the brand new long wave camera that we developed, and it's really a ready-to-use thermographic camera. So first of all, some words about Xenics. So Xenics is the, let's say, the infrared solution supplier. And we have a large portfolio with more than 10 product series in shortwave with line scan, area scan, and also a very strong offer in long wave with swap products, that means optimized size, weight, and power from the QVGA to the SEGA format. And also a very important offer in thermographic cameras. So briefly, where we are, where you can find some Xenics camera. These are the segment that we address, for sure scientific and research, but a lot and more industrial application, some machine vision, process monitoring, all kind of inspection to enable a better industrial process. We also are in safety and security, and now also growing segment transportation and medical. So let's focus now on Ceres T. And what are the key features and what is really new in this thermographic camera? First of all, it's a, and this is very important, it's a ready-to-use camera. That means it has onboard thermographic capability and also onboard automatic corrections. So it's very easy to use and very simple and very accurate. And okay, it's based on a 12 micron pitch sensor. It's very compact, and it gives to the industrial thermographic market a camera which is very close to scientific performance. So some characteristics about Ceres T. It's a VG format, 64480, based on long wave and cooled sensor. It's a thermographic camera. That means there are some calibration packs for the range of -20 degrees C to +120 degrees C. Second one for standard for 50 to 400 degrees C. There has been a lot of work to optimize it in terms of reducing any stray light influence and temperature drift, and also to optimize by compensation for any environmental influence. So the goal is to have something very accurate and very reproducible. So it's offered with a standard industrial, because it's an industrial camera. It's a standard industrial interface, GIGI or camera link. And it's, again, something which is quite compact, important for industry. So 45 by 45 by 67 millimeter, and quite light, depending on the size of the lens. It could be between 242 grams to 378 grams. And above all this, it's quite low power, so less than 4 watts. So at the end, what would be the benefit of all the work that we've done? First of all, I insist on the onboard thermography, which really simplifies the measurement of the temperature. It's radiometric and gives you the value of the temperature, and the integration also is very simple. It makes the camera also more or less interchangeable. I mean, if you change the camera by another with the same lens, you will get the same result. And thanks to the onboard temperature correction, you also have a very accurate temperature, ±2 degrees. That are the level of the scientific cameras. But remember, it's dedicated to industrial application. And you have correction of the temperature drift. So it gives you really stability and so reproducibility. If you switch off and then you switch on, you will get the same result. It's a VGA resolution, so you have a very accurate location, and 12 micron pitch sensor, so that gives you the opportunity to use a small optics. If you reduce the pitch, you reduce the optic usually. So a smaller optic makes a system which is much smaller. So some example of the result. That's what you can get very easily with a picture. Here you have two lights, depending on the shielding. One is cold at 28.9 degrees, the other one is rather hot at 46.17 degree. Okay, so this kind of measurement you can do very easily. Another kind of measurement which is very well known is the temperature of the body. So here you have some people working at Xenics, and the skin temperature is at 34.9, which is standard temperature. So the lady is not is in good shape. No problem for her. And which kind of application are we looking with this? So all what is industrial, such as process monitoring for furnace control, semiconductor inspection, or all kind of machine vision for hotspot detection monitoring, failure detection, sealing quality. Also application in medical with thermology to look at the skin temperature depending on the condition, patient monitoring to be sure that patients are in good shape, and also for sure safety and security with the famous elevated body temperature that is now commonly used in all the orders. So that's what I wanted to show you with this new camera. Again, very stable, reproducible, and accurate camera.
Thank you very much, Marc. Marc.Larive@Xenics.com. Please contact
Exactly.
Marc for any request that you have on this camera. We are very, very amazed of what this camera can do in terms of stability. Marc, once again, epic meeting, epic question. What can you do for them? What can they do for you?
Okay, so what we do is to develop high-performing, reproducible cameras to give as much benefit to our customers. So we have developed these cameras, but we need from the other side some feedback to understand what has to be improved, what should be adapted, and which kind of application you can get also with this kind of stuff. So for us, it's really a discussion that has to be between Xenics and the industrial users.
We have a question for you in the room coming from the CEO of Class 5 Photonics, Robert Riedel. Robert, what's on your mind?
So at Class 5, we build, or some of the lasers we build are mid-IR systems that range between 9 and 15 micron wavelengths. So have you considered your cameras also for laser beam characterization?
So we have some camera that can be used for laser beam characterization, yes, indeed. I don't know whether you need a thermographic measurement, that means the temperature measurement, but at least for beam shape detection and analysis, yes, our cameras can do that. We have some other very small and easy to handle camera, such as the dial.
Yeah, that's really nice. And may I ask a second question?
Of course.
Just out of market interest, so you showed a quite interesting application range. What do you consider as your greatest market opportunity, and what's your personal vision for infrared detection?
Oh, that's a very broad question, a very open question. Let's say Ceres T is a camera which is really dedicated to thermography. So each time you need an accurate and reproducible temperature measurement in your process control, then this is the camera, whatever the process is. Usually it's a process requiring annealing or high temperature or things like that. You need to control the temperature of the item you manufacture or of the tool that you are using, then this is a good camera. But you also have some other application in shortwave or in long wave also, as you mentioned, for example, laser beam profiling, and we have a lot of offer in shortwave and in long wave to do this kind of measurement. Also for spectroscopy, for hyperspectral, we have some knowledge. We do not manufacture the camera, the hyperspectral part of the camera for sure, but we provide to the user the camera that has to be put behind the system. The same for laser beam analyzer. We will provide the camera, and then we will build the analyzer.
There is great room for cooperation here between Class 5 and Xenics on laser beam characterization. So please explore that. But Marc, I want to address with you one market that you presented here. Very, very interesting, elevated body temperature measurements. We still don't know how this market is going to develop. Actually, the epic person on the market analysis, Tracy Vanik, is going to develop a market report on that topic specifically.
Very interesting.
But the question here for me is, we are seeing these cameras going to be everywhere. We are going to see them at the entrance of theaters, football stadiums. Is there a challenge with respect to the volume production? Do you think that uncooled camera operation is the solution? And is the supply chain clear for you? Who is the customer and who is the customer of the customer to address this market?
Yeah, we already are in this market with the previous product that we had for this, the Gobi Plus. But here with the Ceres T, we open a new era because there is no need for additional black body to get accurate measurement. Here, the camera by itself can get ±2 degrees, which is very high accurate. And yeah, the market is definitely growing. We have seen that. Let's say, unfortunately, because of something bad happening these last 2 years, that the market is definitely growing and will continue to grow at all kind of border, or as you said, let's say the big event. There is a need to control there, and yes, that's something we address and we will address with this camera.
In every industrial system, is heat and vibration the enemies. Here you are controlling the heat. I am very curious on why you chose the specification for sensitivity when you were measuring the temperature. Did you have a use case in mind, or did you just go as sensitive as you could? How did you define this specification on sensitivity?
Yeah, let's say we went as sensitive as we could. And the goal is not only sensitivity, but also the reproducibility. In order to do that, we make simulation of the entire camera inside the camera to check what has to be done to optimize the reproducibility. That's a key factor, because usually in industry, when you switch on a camera, you don't want to have a 1 or 2 hour process to scale it up and adjust it. So you switch on, it has to work and give you the good temperature, accurate one, without a big calibration process. So it has to be accurate and reproducible, and that's where we work.
One final question. When it comes to cameras, this kind of cameras in the MWIR and LWIR range, we can actually do many things. Apart from measuring the temperature, we can measure many different chemical compositions. Have you looked at combining this thermographic camera with other wavelength ranges that provide a broader solution to the customer?
If you look at, let's say, the very wide waveband multispectral system, from short wave to long wave, where we are in, for sure, yes, you can combine easily the two kind of camera, because we have some very small and easy to use long wave and also short wave with a common interface. Let's say the graphic user interface is similar, so you can easily switch from one to another and adapt the information you get. Here, with Ceres T, the goal is to get the temperature, really the temperature in the standard range, which is addressable with the long wave.
Very clear. Final question for you. You are addressing here markets with very large throughput. The question here for all the cameras and thermography is calibration. Can you comment on how to calibrate and recalibrate the camera, or is it needed at all to calibrate the camera?
No, the goal is you switch, you get the camera, you switch on the camera, and you get the result.
And that's how we like it. You plug and play. Thank you very much, Marc, for a great presentation. And thank you for making a difference on the long wave infrared cameras. This is a market that we're going to explore and going to expand dramatically in the coming years. And you are one of the top companies on the sector. Thank you very much, Marc. And we go from Belgium to Denmark. We go to one company that is in the cherry on the top of the laser industry of lasers in EPIC, class 5 photonics. Robert Riedel is going to talk to us about the Moonlander HHG, a full solution for time resolved spectroscopy. The floor and the attention of everyone goes to Robert Riedel, goes to you.
Thank you, Jose. Let me share my screen here. So, is my full screen shared?
Perfectly.
Awesome. Welcome, everybody. Thanks, Jose, for this nice event again. I'm Robert. I'm CEO and co-founder of EPIC member Class 5 Photonics. And I'm honored to present you our latest product release, the Moonlander HHG. It's a brilliant tabletop ultraviolet source and a full pump probe suite for photoelectron spectroscopy applications such as ARPES. At Class 5 Photonics, we deliver ultra-fast, high-power laser products at outstanding performance. So we advance demanding applications ranging from bioimaging to ultra-fast material science and even attosecond science. And this includes also our new product line for extreme ultraviolet and soft X-ray technology. Our products are based on robust optical parametric chirp pulse amplification, OPCPA, providing high-power tunable femtosecond pulses at user-friendly operation. Our company won already several awards and provided so far the highest average power OPCPA system ever achieved with more than 100 watt average power in femtosecond pulses. Class 5 Photonics itself is a private company founded in 2014 as a spin-off of the world-leading EUV X-ray synchrotron lab DESY in Hamburg. Currently we have 14 employees and we are now taking the next step towards high flux extreme ultraviolet sources. And we recently won 2 big EU projects in that exciting new field. And yeah, we're just launching our Moonlander HHG source. So let's get on to that. The Moonlander HHG 50 is a high flux coherent EUV source spanning from 21 to 50 electron volts photon energy, or with other words, 57 to 25 nanometers wavelengths respectively. It's designed for time-resolved photoelectron spectroscopy, such as ARPES, angular resolved spectroscopy, or imaging applications such as typographic imaging or coherent diffractive imaging. It has a robust and reliable design for user-friendly operations, and its outstanding value proposition is clearly that the Moonlander HHG is driven by our OPCPA technology. Thus, it serves as an integrated, ultra-fast pump probe suite for multicolor time-resolved studies at femtosecond timescales and nanometer precision. So we really get to the edge of it. Let me explain a little bit more what I'm talking about. So I have prepared this schematic here. For such a so-called pump probe experiment, we have a sample. We pump it with a certain wavelength, and then we can probe it here with extreme ultraviolet pulses. So at Class 5, we designed a laser system that is optimized for such a pump probe scheme using all the benefits of our OPCPA technology. So we can use ytterbium industrial pump lasers with up to 300 watt average power to pump our white dwarf OPCPA. And for one output, the system delivers femtosecond optical pump pulses in the ultraviolet, visible, mid-IR, or even terahertz spectral range in order to trigger the ultra-fast dynamics here in the sample. And for output 2, we designed a tunable near-infrared pulse, for example, here at 800 nanometers, to drive a high harmonics generation source, filtering and focusing setup to deliver high flux EUV pulses for this type of experiment. OPCPA itself has the advantage of high temporal contrast, very clean pulse profile, robust architecture, and very efficient HHG driving. And additionally, the system allows for spectral tunability of the EUV harmonics, which is very interesting for spectroscopy applications. And the Moonlander HHG source itself has the following benefits and parameters. First of all, we offer high rep rate at high photon flux. So we have more than 10 to the 13 photons per second at the source at 100 kilohertz rep rate. And with such a high repetition rate and such high flux, we get overall better measurement sensitivity, right? Better signal to noise ratio, faster data acquisition. And studying solid materials, for example, the measurement resolution is further enhanced because we can avoid space charge effect. We have much less photons per pulse, but still a high flux because of the high repetition rate. And that is a nice benefit compared to low rep rate kilohertz sources driven by millijoule lasers, for example. Yeah, and finally, of course, the spectral tunability in the EUV range allows to address all EUV wavelengths at a very defined spectral resolution that can be set by our OPCPA driver laser. So, in summary, I presented you today our new product, the Moonlander HHG. It's a high repetition rate, high flux EUV source driven by robust OPCPA technology. It's a full optical pump EUV probe suite for advanced spectroscopy, such as ARPES or imaging applications. Please get in touch with us. If you have any questions, we are available via email on our homepage and on our social media accounts on YouTube, Twitter, and LinkedIn. Thanks for your attention.
Thank you very much, Robert. info@class5.com. And I also recommend all of you to check their YouTube site. It's actually quite spectacular. Congratulations on what you are achieving, Robert. This is an epic meeting, so you know what's coming, right? What can you do for them? What can they do for you?
Yeah, what can we do for you? I mean, we can provide high power lasers, broadband, narrowband, tunable, mid-IR, UV, and as you saw today, also extreme ultraviolet light. What can you do for us? Yeah, many things, because we're a laser company. We need all kinds of products for metrology, measurements, like such as cameras, right? We talked about this earlier today. We need optical components, optoelectronic components, vacuum technology, and we are looking for cooperations. It is in our DNA to collaborate, to cooperate, to find new opportunities. Yeah, we love the challenge. Let's get in touch.
You make a big emphasis on the fact that we have fast acquisition rate for this system. What is the problem that you are solving with this fast acquisition rate, and what is the limiting factor? What is limiting the acquisition rate now in this system?
Oh, it depends a little bit on what we want to do, right? The limiting factor is definitely the very often the detection systems. For example, the EUV cameras involved. If you do imaging experiments, there is a tendency towards 100 kilohertz single frame rate experiments, like single pulse experiments. So the community requires 100 kilohertz frame rates of extreme ultraviolet cameras or line cameras. And then depending on the system that is going to be studied, like for example, a solid state material or gases or liquids, there are some limitations in terms of the targets, right? To provide a fresh target for this high acquisition rate. So we run into thermal limits, for example, or just into damaging of the targets during the measurements.
For me, I'm always amazed when I see 25 femtoseconds here. I get fascinated, I get amazed, but I know your other products, so I know the history behind, and it's quite fascinating. But here there is a big challenge when you have to make the analysis of these pulses. This is still always an issue of actually full characterization of that pulse. How are you addressing that? And is there room for some cooperation here with R&D centers and metrology suppliers?
Yes, I mean, characterizing pulses through the whole spectrum is definitely a challenge, and it's also quite an investment for a company to cover UV to mid-IR to terahertz. Cameras, sensors. Now we're talking about EUV, and you know how challenging it is to measure a short pulse in any optical range. Now consider this in the EUV range. There are very advanced applications that all have to happen in vacuum right now. And basically the detection itself is quite complex, but the devices can be definitely provided by the community. So we are happy about anyone who has an idea or who has already a product to come together and see how we can get a step further on that.
Here in the room with us, we have Charles Dumas
Yes.
from Gentech EO. I think you have something in mind.
I was stepping in, so I was unmuted because I was definitely wondering how deep do you go into extreme UV? Is that something around the 13 nanometer, or because it's not easy to measure in that range?
We are on a journey here. So this is the first of a series of product to be launched, and we are starting now in the range between 21 and 50 electron volts, which is 60 to 50, 40 nanometers of wavelengths. We will continue our journey towards the 13.5 nanometers, which is the semiconductor market, right? So, but we have big ongoing projects that bring us in the water window and even towards the kilo electron volt, like towards the 1 nanometer wavelengths.
Okay.
So it's quite challenging to characterize radiation on one hand, on the other hand, short pulses with very specific characteristics.
At Gentech EO, we do have a measurement, I would say, a custom product that go in the vacuum and can measure in the extreme UV. But this is a very extreme application. So definitely, this is the kind of project that Gentech deep UV to terahertz. I think that there's not a lot of business that goes into that kind of range. We are not as flexible for the camera, and we need say Xenics or things like that to measure in that kind of range. But for the power and energy measurement, definitely there's something that we can do here.
That's great. Thanks for getting in touch.
Yeah.
You know, robustness, high repetition rate, stability, upgradability. Robert, congratulations on what you're achieving with Class 5. I am extremely amazed. I have to love everyone equally. I have to, but I can't. I love Class 5 the most. Congratulations on what you're achieving. But I want to continue with the program. We go now to Munich. We go to laser components because they're going to show us the FLEXPOINT MVpulse, a new laser solution with tunable power and pulse length for the machine vision industry. With us is Jochen Maier, the head of the business unit OptoSystems and Laser Components, a company that we all know and love. The floor and the attention of everyone goes to Jochen Maier, goes to Laser Components. I think we have Jochen sharing the screen. Yeah, we cannot see your screen yet, and we are extremely excited about it.
Can you see it?
Not yet. Bottom of the Zoom window, there's an arrow up, says share screen, go to it and then select the window you want to share with the world.
Yeah. So, okay, give me a second chance. Let's try this one.
Thank you very much, Charles Dumas, for the great question to Class 5. I love cooperation. And here we go, all the way from Laser Components, the FLEXPOINT MVpulse. Let's go to presentation mode, slideshow mode. Yes, perfect. Okay. The floor is yours.
Okay, thank you, Jose, and welcome to my presentation. My name is Jochen Maier, and I'm the head of the business unit OptoSystems and product manager for the FLEXPOINT laser modules here at Laser Components. Today, I'm going to present you our new MVpulse line laser for 3D triangulation applications. The MVpulse combines increased laser output power and eye safety in machine vision systems. Machine vision applications normally require as much light as possible, either for shorter exposure times of the camera or when dark surfaces should be inspected. With shorter exposure times, more frames per second can be taken, and for the user it means that the processing time is shorter and more parts can be inspected per second and finally per day. The downside, however, is with a higher laser power, laser safety becomes an important issue and might limit some laser-based machine vision applications. So let's have a look at the status quo at the moment. Laser classification is normally done in continuous wave mode. That's not the best solution and will finally result in a lower laser power. Our new approach is to use the pulse option allowed in IEC 6825, which is the laser safety norm. We classify the laser purely in pulse mode, since most machine vision applications, the laser is triggered with a camera anyway. The red bar here shows the output power for continuous wave laser. The laser is on all the time. We now turn the continuous wave laser into a pulse laser. The laser can be overdriven compared to continuous wave, but only when a defined and controlled pulse length in duty cycle. So here in that example, the red graph shows a laser, a pulse laser, which output power is increased by the factor of 2 compared to the continuous wave laser. In that case, the duty cycle has to be less than 50% and the pulse length shorter than 50 milliseconds. What we can also do is to overdrive the laser, the pulse laser, with a factor of 3 compared to the continuous wave laser. In that case, of course, we have to reduce the duty cycle to 33% and the pulse length has to be shorter than 3 milliseconds. Last but not least, we can go to the factor of 4. And that means, of course, that we also have to reduce the duty cycle once again to 25% and the pulse length with shorter than about 1 millisecond. The problem which comes along with the pulsing is that the trigger and synchronization signal comes from an external source and not from the laser itself. The external signal can be wrong. For example, the pulse is too long or too many pulses should be generated in a certain time. Both can lead to a higher laser class, and laser safety is not guaranteed anymore. So in that case, the MVpulse is now to become what we call a laser pulse police officer. Its job is to first check each pulse. Is the pulse length correct? Is it within the specified limits? If not, then turn the laser off and wait for the next trigger pulse. Second, check the pulse frequency. Is the frequency, the duty cycle correct? Are they within the specified limits? If not, again, turn the laser off and ignore the next trigger pulse. In consequence, the FLEXPOINT MVpulse takes over full responsibility for laser class compliance in pulse mode. What is the result of this new development? In many machine vision applications, continuous wave lasers can now be replaced by pulse lasers to get higher peak power, but still be within the limits of laser class 2. The laser is fully classified in pulse mode by Laser Components as the manufacturer. A misuse is excluded by the internal electronics of the MVpulse that works as the laser pulse police officer. A few words about the technical specifications. The MVpulse is not as big as it seems here in the slide. The standard laser is only 80 millimeter in length and 90 millimeter in diameter. For OEM versions, the optical part can be as small as 40 millimeter by 11.5. Different wavelengths from ultraviolet, blue, green, red are available. The user can choose also fan angles from 5 to 90 degrees. Pulse lasers or laser applications in the machine vision range require a close cooperation between the sensor manufacturer or the system integrator and the laser expert. Call or email us when you're facing limits in your machine vision application in terms of laser power and laser safety. So this is a quick presentation of our MVpulse, the new development. Thank you very much for your attention.
J.Maier at lasercomponents.com. Please do contact him for any request or any challenge or any room for cooperation, or if you simply want to have a chat with one of the nicest people that we have in this network. Thank you very much, Jochen, for being with us. This is, of course, an epic meeting. So you know what's
you.
coming. This is an epic meeting with an epic question. What can you do for these 700 companies? What can they do for you?
Exactly. So let's start what they can do for us. So we're doing something completely new. In the past, all these laser systems and sensors and machine vision, they were all classified in continuous wave mode, which is probably the easier way to go. We are now going the hard way, so to say, and we are now considering the pulse operation. This is something new, and we want to learn from all the users of cameras and lasers if the time is right to go that way. And we need the cooperation with the camera manufacturers, with the sensor manufacturers, and we want to learn if they can adapt to this way of doing the laser classification. On the other hand, what we can do for the EPIC community, we do have a lot of experience in laser classification. So we started more than 20 years ago with doing that, mainly focusing on these so-called eye-safe laser classes, laser class 1 and 2, and the requirements in machine vision applications in the last, let's say, 5 years, well, they are getting harder and harder, and everybody is asking for more light and for more light. And at the end of the day, the laser class 2 is the limit. So we can share all that experience with the community.
At the end of the day, you can tune the power and you can tune the pulse length, and that was very clearly explained by you. You're focusing on the machine vision. There are actually quite a wide range of products for this market. What do you think is the key differentiation point between this product you just presented and other lasers in the machine vision industry?
Yeah, it's the pulsing, definitely, because all these standard lasers, they're classified in the way that they're on even when the camera is not taking a picture, which doesn't make sense. So you don't have to spend, let's say, laser energy when the camera is not taking a picture, and simply turn the laser off during that time. And this will have a huge impact on the laser classification itself. That makes the difference.
For me, when I saw the product, I actually was quite amazed by the aspect ratio itself. Actually, for me, that was a surprise on the aspect ratio of the product. Thank you very much for sharing.
Yeah.
So on this, I think it also makes a difference with the competition. Did you could share with us what made you decide towards this aspect ratio, this size, and especially this form, shape?
Well, we're normally specified in doing or making very small lasers. And unfortunately, of course, that laser pulse police officer requires more space. So that's why the laser will be bigger than our standard lasers. But on the other hand, in some sensor applications, there's simply not enough space to include a huge optics part and then also an electronics part. But we can make the optics part smaller and only have, let's say, a little bit bigger electronics. It doesn't have to come inside an extra housing. We can have it also as a pure PCB or something like that. But again, we are trying to make it as small as possible, but also facing some limits when we need more electronics on the board.
We have a question in the room coming from EPIC's head of photonic market research, Tracy Vanik, all the way from San Francisco, California. Tracy, what's in your mind? Tracy, you are muted. I have a Marc to celebrate such achievement to the EPIC community. And tell us, what's on your mind?
And I did it. Jochen, thank you so much for this great presentation. So I had a question. So comparing your solution to CW versus your pulse solution, will you end up using less power than a comparable CW system?
No, at the end of the day, the average power will be the same, but we will put the light only on when the camera is taking a picture. So if we really measure the average power with a sensor or something like that, you will see the same amount of light, but we will simply only use that light energy when the camera is taking a picture.
Understood. I was wondering if you might be able to save power for the users so that they're not using as much electricity to drive your laser, or does it?
Yeah, no.
So
that's not the main goal. The main goal is still have to have a lot of light when the camera is taking the picture.
We don't.
And you will provide that. That's great.
We do that.
Thank you very much, Tracy and Jochen. We don't talk about price here. I don't. But for the audience, check about the cost effectiveness of this product because it's also quite outstanding. Congratulations, Jochen, on what you are doing. It is great to have you in EPIC. We continue with the program and we go to one of the topics that I love the most. We go to Superpolished Optics. We have, I think, the market leader and the beloved company in optics in the world, Edmund Optics, presented their product range on Superpolished Optics, and nothing less than Angelica Compatangelo, the technical marketing manager of Edmund Optics, telling us how we can all help with our specifications and requests, make Edmund Optics even greater and more amazing than already is. The floor and the attention of everyone goes to Angelica.
Hi, Jose. Thank you very much, Jose, and everyone at EPIC. I'm just going to share my screen now. All right. Hi, everyone. I'm Angelica Compatangelo. I'm the Technical Marketing Manager here at Edmund Optics Europe. And today I'm going to be presenting to you our new range of Superpolished Optics products and technology. So the basic issue with a lot of optical system is the scatter. So when you have scatter, you tend to have loss of power and just general decreased system efficiency, which is an issue really for precision high power or UV laser applications. You don't want that. And related to this is actually the surface roughness, because the more roughness you have, the more scattering you're going to get. And again, we don't want that. So what we are proposing at Edmund Optics are some super polished optics to mitigate this effect. So currently we have a range of super polished substrates with ultra low surface roughness available off the shelf and custom capabilities to give them custom capabilities. So we can do any size that you want. All right, so what does super polished actually mean? So there's no true industry standard for what a super polished optic actually is. So companies typically use this as an umbrella term to denote anything that is from a nanometer to a angstrom surface roughness. Which is actually a huge difference in terms of order of magnitude. Now, here at Edmund Optics, we've actually developed a process to polish surfaces to a sub-angstrom RMS surface roughness. So just for a sort of visual comparison, I have some AFM sort of images here.
I think we have some connectivity problems with Angelica. Angelica, can you hear us? 1, 2, 3. 1, 2, 3. Oh, it is a pity because now we found out what super polish mean, or like there is no definition for that. But Angelica, are you with us?
I can hear you guys. Can you guys hear me?
Now we can, and loud and clear. Please continue.
Okay, apologies for that. It's the occupational hazards of working from home with an unstable connection, so apologies. Yeah, so as I was mentioning, here is an AFM picture of a surface that is 3.5 angstrom in roughness. Here's one that is 1.5 angstrom in roughness. You can already kind of see here that the surface is a little bit better, but still not super great. And this is an Edmund Optics super polished surface. So as you can see here, in terms of comparison, it is already a lot sort of better. So this is all well and good, Angie, but how can you actually, verify that you are actually getting sub-angstrom surfaces? So here at Edmund Optics, we always say, if you can't measure it, you can't make it. So we actually have an extensive metrology suite with a lot of our manufacturing locations, and specifically relating to super polished optics, we're using data correlation between atomic force microscopy and white light interferometry to reliably measure the sub-angstrom specification. If you want any further information on this, we published a paper on surface roughness in the SPE conference proceedings, so you can have a look at those. But let's get on to the actual products. So we currently have in stock, off the shelf, a range of super polished laser window substrates that are super polished to less of an angstrom RMS surface roughness on both sides. Currently, we have them in a fused silica material with sizes between sort of 12 and 50 mil, but we are actually going to bring out very soon also a 76 mil standard version of this. Because of our in-house manufacturing, we are actually also able to do these custom for you. So in terms of our custom capabilities, we can do all sorts of shapes and sizes, sort of between 6 and 100-ish millimeter. We are also able to apply some of our high power or complex laser coatings on these. So if you need a specific coating on the substrates, please let us know. And then in terms of next steps as well, we are focusing on actually super polishing curved surfaces. So at the minute, we are looking at super polishing curved fused silica, specifically with an initial focus of plano-concave surfaces for things like laser cavities. However, additionally, we're also looking into ulterior materials, so things like calcium fluoride or sapphire. So if you have any kind of requirements for those, please let us know. So let's have a look at who actually benefits from super polished optics. So typically would be applications with high power lasers, where energy is really like a big, well, energy loss is really a big deal, particularly when you're at the kind of like kilowatt laser sort of range. And actually there are indications that super polishing actually give a higher laser damage threshold, which is an added bonus. Then because scatter scales nonlinearly with wavelength, UV applications such as medical systems like eye surgery or other UV applications such as photolithography can also benefit, and ultimately sensitive application where throughput is essential, such as metrology, things like cavity ring down spectroscopy, fluorescence detection systems, and the like. So very briefly, before we conclude, just a quick word about Edmund Optics. We are a designer, manufacturer, and distributor of optical photonics and imaging component, and we can provide to you low volume prototype quantities as well as the higher volume OEM production quantities. So thank you very much for listening. Please let me know if you have any questions.
AC@edmundoptics.co.uk. Thank you very much. If you have any question about super polished optics, or you simply want to have a nice chat about super polished optics with a fantastic person, contact Angelica at ac@edmundoptics.co.uk. Angelica, you're not going to be surprised by the question that is coming to you now, right? The epic question. What can they do for you? What can you do for them?
All right, so what can Edmund Optics do for you? Well, we can provide you with super polished substrates and fused silica. We can also develop this on other materials as well, if you require. We can couple this to our high power complex laser optics coatings to give you a full solution for glass and crystalline materials. Actually, one of the coatings that we're working on applying this to super polished is IBS ion beam sputtering coatings. And what you guys can do for us, well, we're always really interested to know what you are all using our components for. So if you can let us know sort of what applications you're using it for, maybe something that I haven't mentioned before. Also, what kind of shapes and sizes do you need? What kind of coatings are you wanting on them? What sizes? What kind of materials? So this is all really sort of useful information for us and great for us to know.
When I saw your presentation, I was actually quite amazed by that you have 3 different standard sizes, and then you have you say, these are my standards, but then you want to have any shape, I will make it for you customized. Why did you choose these 3 standardized sizes? If I know well, these are not these are not standardized globally, right?
This is a good question. So these are kind of standard sizes in that they are sort of quote unquote metric sizes, like the 12.5 or the 25 or the 50. But they are essentially the sizes in inches. So it would be half an inch, and then 2 inches. But they're roughly sort of the sizes that most standard optical components are. So a lot of, it's not too difficult to find sort of mounting or holding options for these sizes anyway. They're relatively common, I would say.
one of the main applications for superpolished optics is the high sensitive lasers. High sensitive lasers for many, many different applications. What kind of companies, what kind of laser manufacturers have you scouted, and what would be the right epic introduction I could make to those for them to do business with you?
So as I mentioned before, we're always interested in whoever is sort of looking at using these sort of components in their laser systems. One thing in development that we have, as I mentioned, is the plano-concave surfaces for things like laser cavities. So if you are in that sort of business, please reach out to us. But as always, we are more than sort of happy to even take, somebody who's in a related field and say, okay, well, I want this super polished optic in this size because it fits my application best.
I actually do have a company here in the room for that. You're talking about high sensitivity optics and have super polished optics for reducing the scattering of light in the system. Robert, when it comes to super polished optics, where do you stand? Is there some room for cooperation here?
Yeah, Angelica, thank you so much for this presentation. I was thinking about our EUV product line, and especially, as I mentioned earlier, if we go towards 1 nanometer wavelengths, right, then surface quality becomes crucial for such applications. So when we have surface roughness in the Armstrong regime, then we are well below lambda over 10, which is quite nice to learn, at least for normal incidents. So it would be a great benefit to use such substrates for coating applications. Regarding curved optics, how are your capabilities to polish also not only spherical but also like toroidal or even elliptical mirrors, for instance?
Ooh, you're asking the hard questions now. That is a great question. I don't know if we have actually looked into those more sort of like complex surfaces, but I am sure that we can double check with our laser optics manufacturing gurus and get back to you on that one.
For anybody in the room, if you are developing a laser-based sensing system for gyroscopes, for laser trace, for gas trace detection, these are the optics that you need. Thank you very much, Angelica. And thank you everyone for a fantastic session. I really enjoyed it myself, and I really organize these meetings almost every week. So for me, it is great to enjoy my job. So thank you for making my life very simple. It looks like the meeting is over. The meeting is not over. The most important part of the meeting starts now. For everyone who has watched these presentations, if you want to get in touch with any of the participants, I share their email address, but also please send me an email and say I want to talk to them about this particular business opportunity. jose.pozo@epic-asset.com. Send me your request, send me your Santa Claus Christmas list, send me your needs for cooperation. I love to hear them and I love making introductions. Here we are talking on behalf of a fantastic team of people. We organize online technology meetings. We know your technology. We find ways of raising capital. We have the biggest website to find a job in Photonics, jobsinphotonics.com. And everybody in EPIC has a list of market reports accessible for them because we love seeing the companies grow. Talking on behalf of a fantastic team of specialists on the medical, on the integrated photonics, on the laser, on the optics, an innovation manager, marketing and communication experts, or CFO, and who doesn't know Carlos Rio, CEO? Stay healthy, wash your hands, wear a mask, get vaccinated as soon as possible, because I can't wait to start traveling again. See you soon. Bye-bye.